네, 저는 지금 여기 뉴욕대 메트로텍 앞에 나와 있습니다. 전 세계 4대 석학 중에 한 명이자 이곳 뉴욕대 프로랜드 수학연구소 교수인 얀 루픈 메타 수석과학자가 한국 언론들과 인터뷰할 자리를 마련해 줬습니다. 메타에서 오픈소스를 기반으로 인공지능을 연구해야 한다라고 주장하고 있는 이 과학자가 생각하는 AI의 미래는 어떤 모습일까요? 인터뷰를 통해서 들어보겠습니다.
Welcome everyone. This is called the Global AI Frontier Lab, and there are a certain number of words here that I think are really important. Okay, so frontier is one word. There's much to do in AI. And what this lab is about is pushing the frontier. We sometimes get the impression that AI is a solved problem. You will hear this from certain people in industry, not so much in academia, claiming that that's it, we solved the problem, it's just a matter of getting bigger computers and more data now. This is not true. There is a lot of very fundamental research to do, very important research, to bring AI systems to the level of intelligence that we observe in animals and humans. We get fooled by the fact that current AI systems can manipulate language. And we're only used to the fact that whenever we face an intelligent entity, another human, they can manipulate language, so we associate language with intelligence. But a lot of AI systems today, despite the fact that they manipulate language, and despite the fact that they have a lot of memory capacity and can read enormous amounts of material and integrate it, they're not that smart. So really, this is the frontier. How do we get AI systems to really become smart? They're not yet smart. But we're making progress on that. The second word, which I think is important, is global, and I'm going to speak to this a little bit. Robotics, I think, is an important thing to look forward to because the coming decade is going to be the decade of robotics. Robotics is something that has taken longer than everyone expected to really emerge. And the reason it's taken such a long time is not because we cannot build the robots, it's because we cannot make them smart enough. So we have AI systems that can pass the bar exam or, manipulate language, as I said before, write essays for us and things like that. But where is our self-driving car? We don't have level 5 self-driving car, a task that any 17-year-old can learn in 20 hours of practice. We don't have domestic robots. We don't have domestic robots that can clean the house, that can clear the dinner table, fill up the dishwasher, a task that a 10-year-old can learn in one shot without being taught, essentially. So what that tells you, as I was saying earlier, we still have a long way to go to make machines more intelligent. And until we have systems that are capable of doing this, we can't claim victory. So robotics is going to play a very important role in the progress on AI, also interaction with the physical world. Right now, AI is limited to text. Is an interesting calculation to do. A typical large language model is trained with 20 trillion words, tokens, but it's the same as words. Each of those tokens is stored on typically 3 or 4 bytes. So the total amount of data that an LLM is trained on is something like 60 trillion bytes. Okay, it's a 6 with 13 zeros behind it. Okay, maybe a 1 with 14 zeros to round it. That's an enormous amount of information. It would take any of us a few 100,000 years to read through that material. It's all text. It's basically the entirety of all the text available publicly on the internet. We might be led to believe that those systems are extremely smart because they've been trained on so much data. But in fact, talking to psychologists, they tell you that a 4-year-old has been awake a total of 16,000 hours in his or her life. And in 16,000 hours, if you do a rough estimate of how much information got to the visual cortex or the sensory cortex through touch, it's about the same amount. It's about 10 to the 14 bytes. So a 4-year-old has seen more information through vision or through touch than the biggest large language model that we have today. So that tells you is that we're not going to reach human level intelligence by just training on text. We're going to need to get systems to learn how the world works by watching the world go by and by interacting in it. So that's a big challenge, technical challenge for the next few years. And the price for this is two things. Maybe domestic robots, self-driving cars, systems that have common sense, things of that type. But also, AI systems may become the repository of all human knowledge. And that leads me to this second word in the name of the lab, global. We need AI research to be global. We need it to be open, and we need to be global. Because we need to build a technology that will allow AI assistants of the future to speak every language in the world, translate from any language to any language, understand all the world's cultures, understand all the world's value systems, centers of interest. And the reason for this is that there is a future, not too distant, in which every single one of our interactions with the digital world will be mediated by AI systems. So we're going to get all of the information through AI systems. You already see a few companies that basically use AI as kind of a basic technology underlying search engines. You just ask a question, and then the system answers the question, and then perhaps gives you links to original documents. It's a different type of search engine. You see this also in social networks that now give you a possibility of interacting with AI systems and asking a question or comment on a post that you just saw. Because all of our interaction is going to be mediated by AI systems, we need those AI systems to be diverse, speak every language, understand every culture, and give a choice to everyone for what language, what culture, what value system they expect from their AI system. We need diversity in AI systems for the same reason that we need diversity of the press and the media. And that can only occur if research in AI is done in the open and if AI platforms are open source. What future does that give us? Some people feel threatened by the idea that one day machines will be smarter than us. But if you are a leader in academia, in industry, and certainly in politics, you are extremely familiar with working with people who are smarter than you. I'm certainly familiar with this. And this is going to be our relationship with AI systems in the future. They may be smarter than us in certain areas, but we're going to be their boss. They're going to help us solve problems. AI assistants will be with us at all times, and they're going to amplify our intelligence the same way a staff of smart people working for us amplifies intelligence of leaders. This is going to be our relationship with AI systems. We need to build AI systems that do that for us. But if we succeed, the impact of AI perhaps on society would be similar to the impact of the invention of the printing press in the 15th century, in the sense that people will be just smarter for it. And the impact of the printing press was basically to enable the Renaissance and the Enlightenment and a complete change of the organization of society. AI may have the same effect, and we need to work towards maximizing the benefits of that effect.
Yeah, that's a complicated question. So, first of all, the progress in AI has not been linear or exponential. It's been very intermittent. So there was fast progress in the 1980s, and then slower progress in the 1990s, where the techniques that have become prominent today, deep learning, essentially abandoned for almost 15 years. And so almost nobody was working on deep learning, which is the basis of AI systems today, between, let's say, 1995 and 2005, or even a little later than this. And then there was a renewal that occurred during the late 2000s, and that renewal led to breakthroughs in the early 2010s. The first breakthrough was in speech recognition. The second one in image recognition around 2013. The third one in natural language understanding around 2015. And then since then, there's been an acceleration of progress, largely because of investment from industry. And because also the attractivity of AI for young students motivated a lot of people to study AI and afterwards do research in AI. So the difference between what's happening today in AI and what's happened in previous waves of interest in AI is that now there is a big industry around it. And what's driving the innovation is the prospect of success. But indeed, it's a big question as to what is the right level of investment. Is it going to be the case that within, let's say, 10 years, 5 to 10 years, we're going to have breakthroughs that will allow us to reach, if not human level intelligence, at least make progress towards that? Or is it the case that, like in previous waves of interest in AI, we're going to hit a ceiling and performance is going to saturate, and we're not going to find a new set of methods to really make significant progress? The two scenarios are possible. If the first scenario occurs fast enough, then the current investment will not be a waste. If the second scenario is the case, and research basically saturates and slows down, then investment is going to go down, and it will look like it was a bubble. You know, being at the forefront of the research, trying to push the science and the technology forward, as this institute is going to do, and as the lab I created at Meta Fair is also trying to do. A lot is riding on the success or not of those. So different people have different opinions about what the way forward is. Some people believe that we have all the techniques we need, and what we need is just bigger computers and more data. I do not believe that's the case. What I believe is the case, and I wrote a long vision paper about this 2.5 years ago, is that there needs to be a new type of architecture for AI systems beyond large language models. Something completely different. Large language models would be part of it, but they will not necessarily be the central piece of what we're talking about here. So you have to make a distinction between the short term and the long term. So in the short term, a lot of applications that are going to appear based on LLMs with some modification and improvements, right? So LLMs that have access to search engines and memory, LLMs that are agentic, which means they can produce actions like a search, calling a calculator or a mathematics engine or a search engine or a database query. And then LLMs that are minimally modified so they can do some level of reasoning, but the reasoning ability of LLMs are very limited. So that's the first thing. And then some research labs, Meta Fundamental AI Research Lab in particular, but also DeepMind, are working on the next generation AI systems. That next generation are systems that understand the physical world, have persistent memory, a little bit like humans and animals have a hippocampus, which is the seat of memory in the brain, can reason and can plan. And this requires completely new architectures that are not LLMs. LLMs can be part of it, but they're not the essential component. And this is for the longer term. The impact of those architectures may occur in 3 years, in 6 years, or in 10 years. We don't know because it's still very much at the research level. We have good hopes that the impact will be in relatively short term. So we'll have systems that understand what goes on in a video and understand what's possible and what's not possible, probably within the next few years. And that will give AI systems a certain level of common sense, which they don't have at the moment. Current LLMs are very limited in the sense that there are kind of standard questions you can ask them to test whether they have any kind of common sense or reasoning ability. So you ask the standard LLM the well-known puzzle that we ask children, where you have a wolf, a sheep, and a cabbage on one side of a river, and you have a boat that can only transport 2 objects at the same time. And of course, the wolf can eat the sheep, and the sheep can eat the cabbage, right? So the solution to that problem is, you take the sheep first, and then you take the cabbage, you bring back the sheep, you take the wolf, and then you take the sheep, right? So it requires a number of round trips. Ask that question to an LLM, it will just give you the answer. Now change the statement of the problem a little bit, saying there's just a cabbage. And the system will still tell you you have to go 3 or 4 times between the two sides, because what it's doing is that it's just regurgitating a solution that has been trained on. It's not actually thinking, it's not actually reflecting, it's not reasoning, it's not planning, it's just regurgitating. Okay, it's like rote learning. And we see that in a lot of experiments with LLMs. There are things also that are very basic, right? Computers can count and figure out numbers, but if you ask most LLMs, what is larger? Is it 9.8 or 9.11? And they will say 9.11 is bigger because 11 is larger than 8, but of course that's completely wrong. So those systems are very, very limited at the moment. And we're going to see a phase over the next few years where some of those shortcomings are going to be improved slightly through a little bit of planning, a little bit of retrieval from databases and things like this. But eventually, what will really bring a big progress is a completely new paradigms. Systems that are trained from video. Text is a very low bandwidth medium, and that there is much more information in just a few thousand hours of video than there is in the entire text available on the internet. So we need systems to really learn how the world works from video, like humans, like baby humans, but like also your cat and your dog. Okay, so AGI is an interesting question. So first of all, it's a misnomer. It's a bad phrase, okay, because there is no such thing as general intelligence. Human intelligence is very specialized. The people who use AGI to designate human-level intelligence are making a mistake. Now, unfortunately, this is the phrase that everyone uses, but it's a bad name. Second element, the emergence of human-level AI or AGI is not going to be an event. It's not going to be a singular event where there is before and after. It's going to be continuous progress over the next decade, maybe 2 decades. We don't know. And, there's going to be breakthroughs. For example, the first breakthroughs that I'm expecting, that I'm working on, is systems that can learn to understand the world like animals and humans by watching video, basically, and maybe a little bit by interacting with the world. We don't know how to do this today. The type of architectures that are necessary for this are not large language models. They're not even generative models. Okay, so everybody is talking about generative AI. The systems that will work for video are not generative AI. It's a different type of architecture. I call it JEPA, that means Joint Embedding Predictive Architecture. But I'm not going to go into the technical details, but there's quite a bit of work on that. Then we're going to have to train those systems to really understand the world. Understand that, if I push on this with a particular force, it moves. If I push on the table with the same force, it doesn't move. I know that, right? I have an internal model of intuitive physics. How do we get machines to learn this? Your cat can learn that in the first few weeks of life. We can't do it with computers yet. So that's a big challenge. So once we have such world models, we'll have systems that can reason and plan. They might be able to imagine what a sequence of action will produce. That's what we call world models. And then those systems will be able to plan a sequence of actions to arrive at a particular goal. I call this objective-driven AI. So those systems are a completely new breed of AI, completely different from LLMs. They don't work yet. It might take 5 years for us to get them to work. It might take 10 years. Or it might be much harder than we think, and it might take 20 years. So if the time frame is, let's say, 5 to 10 years, the current investment in hardware and research is justified. If it's 20 years, no. Certainly in the ethics of AI, there are very important questions that attempt to address real risks and problems. But then there has been also a lot of excessive exaggerations of the tangents. So I've been pretty vocal in dismissing the idea that there is existential risk attached to current AI technology or even future AI technology if we do it right. I think the people who are worried about this is small number, but extremely vocal. And so they have more impact than they should, really. And I think those fears of existential risk are causing some governments to establish regulations that are actually counterproductive and make AI more dangerous, not less dangerous. I think the proper way to develop powerful AI systems is basically by sharing scientific and technical information and open source platforms, because we need those systems to be diverse, speak all languages in the world, and understand all cultures. And if we establish rules that are based on the idea that AI is intrinsically dangerous, we run the risk of essentially making open source AI platforms illegal. And that would be very dangerous, because the result of this would be that AI systems will be produced by a handful of companies, most likely on the west coast of the United States. Are they going to speak Korean? Are they going to speak French? Are they going to speak all the dialects that are spoken all around in the world? No, because they would need to get the data and they can't really obtain it. So this is a future that, people who are well-intentioned because they're worried about the future of humanity actually have a counterproductive effect, because they stop the sharing of information. The incredible acceleration of research and results in AI over the last dozen years is due to open exchange of information. So AI within science and within computer science even was very early on one of the first one to adopt an extremely fast way of publishing papers, for example, by sharing them on archive.org, which is a preprint repository, before they go through peer review and everything. AI is notorious for a lot of scientists sharing code, which really accelerates progress enormously. And so the reason why we've seen AI progress so fast is because of the free exchange of scientific and technical information all around the world. Now it's changing a little bit. Some industries, some companies, in an attempt to preserve what they think is their advantage, are climbing up. They are basically not communicating technical and scientific information nearly as much anymore. That's the case for OpenAI, it's the case for Anthropic, it's the case for Google to some extent. Happy to say it's not the case for Meta. Meta keeps publishing and distributing its code in open source, which is one big reason why I'm affiliated with Meta and not other companies. But I think this free exchange of information is really, really crucial. Okay, so that's one aspect of risk, right? And then there is the other aspect, which is AI systems reflect the biases in the data. A lot was written about this, but the main cause of bias in AI systems is the statistics of the data it's trained on. So LLMs today manipulate English really well because there is a lot of material in English on the public internet. They don't speak a lot of other languages for which there is not nearly as much content freely accessible on the internet. And that's an issue, because we need AI systems to speak, not just English, Korean, French, and German and Spanish, but also Wolof, one of the official languages of Senegal, or Kannada, which is a local language in southern India, or all the languages in the world. There are about 7,000 languages in the world, about 2,000 of them in Africa. We need AI systems to be able to understand this. This would be a way also to bridge the AI gap. We were talking years ago about the digital gap, the fact that some people have access to digital information and others don't. That gap has been bridged largely, but there may be an AI gap. But my belief is that AI will actually reduce the gap because it makes technology accessible to people who previously could not access it. So you can have a farmer in a remote corner of Africa or India just speak to their phone and get information about weather or agriculture or whatever it is, without having to learn anything about computers or the internet or anything, right? So AI will actually make technology more accessible to a wider population of people. And it will also enable people to speak in their own language. Okay, today, there are smart glasses that you can talk to, and they have an AI assistant in them. There's one model made by Meta called the Ray-Ban Meta. They also have cameras, and you can ask that system to explain what you're looking at. It's going to take a picture and just tell you what you're looking at. If I'm in Korea and I go to a Korean restaurant and I look at the menu in Korean, I can ask that system to translate this for me. Okay. The nice thing in Korea, though, is that a lot of restaurants have pictures, but that helps too. So the future is one in which we'll have access to those AI assistants, and it will lower language barriers and cultural barriers. By next year, there will be a number of smart glasses and other smart devices that have not only cameras and microphones and speakers, but also displays inside of the glasses. They can overlay information on top of the real world. So you can have real-time subtitles. You're speaking to someone in a language you don't understand, and you would have subtitles appearing in real time in your glasses. I think that's going to be it's going to be a game changer. It's going to be a huge impact. Okay, that's an interesting question. So there have been efforts, various government sponsored efforts in various parts of the world to build local LLMs. There's been efforts in France, in some other European countries, in the UAE, the United Arab Emirates, with the Falcon project. In France, it was called Big Science. It's more of a European project. And of course, there are efforts in China. Ultimately, though, those systems did not end up gathering too much interest from industry. And the reason is because they were far behind what can be done in the top tech companies. The advantage that the big tech companies have is that they've made considerable investment in talent, expertise, and computing resources. Training a large language model like Llama or ChatGPT, so Llama is the one produced by Meta, or the GPT family or Gemini from Google, requires enormous computing resources, a lot of expertise, hundreds of engineers, thousands of people fine-tuning those systems, and the cost is astronomical, and it's growing, but the performance is saturating. So we're reaching diminishing return. So I don't believe at this time that a government effort anywhere in the world can match that, because that would require enormous investment. Just a data center, a sort of AI-focused data center with something like 16,000 GPUs, which is a bit of a unit, costs over $1 billion. And that's not sufficient for training a top LLM. You need a few of those. The amount of GPUs that Meta, for example, will have by the end of the year is on the order of 500,000. And the investment is in the tens of billions. It's enormous. And then you need people who know how to make them sing. And it's going to be very difficult for government to attract the right talents when they are in competition with tech companies that pay people extremely well. I think the best approach to this is that companies like Meta is a bit unique in that respect. Open sources its model, right? Its best models are open source. They're distributed. Anybody can use them for free, including for commercial use. And that constitutes the basis of a whole ecosystem of AI system. What's going to happen in the future is that Meta cannot do it by itself. The amount of computation and data that is required is so large, and the amount of diversity of data that we need to get is so large that this will have to become collaborative projects. So Meta is already trying to collaborate with governments around the world, in India, UAE, various other places, perhaps in the future Korea, so that the future open source systems that are produced by Meta speak all the languages that are required, all 22 official languages in India, for example, understand all the local culture and everything. And for that, what's missing is data. That can come from partnerships. But I don't think governments can do it by itself. No, there has to be a partnership with the tech industry. Right now, Meta, which is pretty much the only big one that open sources this model, is an objective ally to AI sovereignty outside the US. A number of European governments have understood this, and I think it's the case in Asia as well.